Hey.
There we go. We are live.
Cool.
Hey. I'm waiting for someone to say, I see you. And they tell us how we screwed it up. And I'm running the newest version of online broadcast system. So it could work.
I think I'm going to actually be installing that.
OBS, you need some tutorialing on that?
Yeah, that would be great. We're going to probably start using it for the Center for Lunar Exploration and Science. I got those in the wrong order.
Mm-hmm.
For a different set of podcasts, not podcasts.
Okay. Yeah.
Hangouts I do. Words, they're hard.
I know. Okay. What was I gonna say? Oh yeah, it's cold. So cold. It's been like going down to like -10, -11
Celsius.
Celsius. Yeah, it's been super cold.
Yeah, we're the exact same place. We have snow outside, which means I really had to close the blinds because glare, and I'm still getting a lot of glare coming in from outside.
You're gonna close those blinds, or
Yeah, I'll do that.
how is
Oh,
it that you don't have some kind of smartphone app that lets you do this?
because my house was built in 18 not enough.
Yeah, but you technologically refit everything that you come
I
in contact with.
do. I just our windows are weird. We need to replace all the windows, but custom fit windows are like $200 per window.
No, I was thinking some kind of machine, some kind of robot that just closes your blinds and closes them, opens them back up again. That's all I'm thinking.
Those are going to cost more than Hue light
I
bulbs.
guess so. But yeah, cool. So I went out to try to do some astrophotography last night, uh, and it didn't go so well. So the
Oh
first
no.
half of it went really well. I took some great pictures, and then I realized that I had the f-stop. I have my 14 millimeter, like a really great wide open lens, but I had the f-stop in the completely opposite side of it, so down to f22, which was not helping. So then I although the pictures were pretty good, but it wasn't sort of sensitive enough. So I flipped it all the way around, and then started taking more pictures. But I forgot to refocus the lens, and so
Oh,
all the pictures that I took after that are completely out of focus.
oh no. You
And
had
what I was
all
trying
the
to get
day.
was right now, you go look at the moon. Like I'm sure everyone's seeing the moon and everyone's seeing Venus right now, and they're super,
Yeah.
super bright. But you can also see Mars and with the naked eye. And then if you use a camera, you can see Neptune and Uranus all together. In fact, tonight, Uranus and the moon are going to be like 3 degrees apart. So like this far apart, held at arm's length, which is great. But you need to use a camera to be able to see it.
Yeah.
So, but they're all there
Uranus
right
is
now. So I tried to get a shot of that, and I sort of half failed miserably. So I'm gonna try another crack at it tonight. But the forecast is for snow for like 5 straight days of snow here,
yeah, we
and rain.
have snow here and it's it's the same temperature as with you and it's actually supposed to get down to like -15 tonight.
Oh,
Yeah.
Hugo Burnham, unaided eye, Fraser. Yes, unaided eye. I just did something to you, Hugo. Enjoy. Okay, so I'm gonna say hi to a bunch of people.
Go.
Adam Synergy, Alex Desplund, Brian Stab, David Joseph Wesley, DKTAZ00, Dusty Reichman, Guido Bieber, Helge Berkog, Hugo Burnham, James Bond, Jessica Feltz, John Seffel, Keith Irvine, Lillian Brennan, Michael Meyer, Mustafa Farouk, Nancy Graziano, Pamela L. Gay, Paul Gracie, Richard Strassel, S. Wolberg, Sergio Patero, Seth Cooper, Tech Tang, Jessica Feltz, Tom Van Scotter, William Satterwhite, and Zach Cody. Welcome, all of you. All right. Paul Gracie says the juvenile jokes about Uranus and the moon come to mind. Zach Cody says only -5 on Lake Ontario. Yeah, so Eastern Canada is warmer than Western Canada, which is normally exactly the opposite. That
Yeah,
is not
that's not
right.
normal.
People move out here to get away from your cold. Keith
Right.
Irvine says it's -22 in Manitoba, so that sucks. but Winterpeg is just always just awful. So it's so cold, like -4, colder. What do they say? Colder than the surface of Mars at times.
Yes.
Yeah, there are
Yeah.
times when Winnipeg is colder than where Curiosity is exploring. Question comes from Sergio Botero. Can you see Uranus with a regular telescope camera? Yes,
Yes.
totally. In
Yeah.
fact, it
You can
is.
see with binoculars if you
You
know where
can see
you're
with binoculars,
looking.
and it is just. Oh, I should take the binoculars last night. Okay, I'm gonna do this right. If it's clear tonight, I'm gonna do this right. I'm gonna go up the mountain and get to really dark skies and really go the whole distance here. Yeah, you can totally see Uranus with. In fact, if you're in really dark skies, you can theoretically see it with your own eyeballs, but that is sort of the a challenge.
It's a
But
good challenge.
yeah, but
Everyone needs a
yeah,
challenge.
binoculars, small telescope, definitely with a DSLR, you'll totally be able to see it. Will you be able to see Neptune? Yes, yes, you can see. You can take a picture with your DSLR, run the exposure for a long time, and you should be able to pick out Neptune and Mars and Venus and Uranus all in the same picture, which is really cool. That is my plan.
It's a good plan.
It
I
is a good
approve
plan.
of
I have
your
a good
plan.
plan. Okay. So if you're wondering what on earth this is that you have stumbled into, first, did anybody just see my story on Instagram where I just said that we are going to do Astronomy Cast and then you came here? Let me know if that happened. If you haven't already, you should totally follow me on Instagram. Follow Universe Today. We're having a lot of fun with that. I'm giving you a new
Yeah.
thing to see every day or every couple of days in the night sky.
And you bring in stuff from so many different people.
Yeah, I'm bringing some. So I'll be mentioning this in the show, but Dave Dickinson wrote the 101 astronomical events in 2017, which is a free book that we just gave away. It's 220 pages, totally free. Just come to Universe Today, pick it up. And then, of course, I'm bringing in some stuff from our good friends at the Year in Space. Boom. If you haven't already got it, it's not too late. Get this one, and then, of course, sign up for the 2018 one. Once again, they don't pay us any money. They're just friends. Today, Thursday, what do we got? First quarter moon at 2:47 p.m. Uranus, 3 degrees north of the moon. In 1969, Venera 5 launched. In 1972, President Nixon announced approval to develop the space shuttle. And in 2005, UB313 Eris was discovered, igniting the Pluto planet debate. Nice work, Mike Brown. Okay. So there you go. I'm not going to do this every time, but I'm doing something kind of like this on Instagram. So, total experiment. Follow Universe Today on Instagram, and I'm doing stories every day. Stories with Fraser. Okay, so yeah, if you're wondering what you stumbled into, we're going to do an episode of Astronomy Cast live right now, and you're going to watch it happen, and then we'll stick around afterwards and answer your questions about space and astronomy.
Yes, this is our goal.
Michael Myers says, Fraser, be careful with long exposures and long lenses unless your camera's on a tracking mount. It is not on a tracking mount, but I have a 14 millimeter, so it's super wide angle.
Yeah,
so it can do 30 seconds as long as my camera will go, but I want a tracking mount. In fact, if you can recommend me a tracking mount, I may just buy one. Unless Celestron wants to sell me one.
I have a Celestron one that's actually quite nice. It's designed for DSLRs.
Yeah?
Yeah.
Do you like it?
And it was recommended by Peter Lake.
Yeah? Do you use it?
I've used it a few times. I don't have a horse right now, so I'm not going to a dark sky site. I need a new horse. We'll take more astrophotos.
How is a horse needed for this? How does the horse fit in?
I'm lazy.
Okay.
And if I'm going to ride the horse, I drive to the dark sky site and visit with the humans and the horse, and then the sun goes down and I take pictures.
Your audio just went wonky for a second there.
I was talking really fast.
No, like it jumped, like you're extra quiet right now.
Really?
Yeah. And then
it's still really quiet.
I don't know if anyone else heard that, but it was sort of weird.
Is it back to normal?
It's back to low. Can you go to like just start up, like jiggle your cables?
Yeah, that's.
I can try boosting your levels a bit. Talk.
Hello.
Yeah, I'm gonna bring you up a little bit. Okay, try it now.
Hello.
Michael Millard, have you got a tracking horse?
That would be amazing and very slow.
Now you're a little loud again.
I'm deeply confused.
As long as the audio coming, just watch your audio coming into Audacity and
Okay.
just watch your levels and just make sure that it's not getting blown out. Okay.
Okay.
And if it
I
happens
will
again,
do
I'll let
that.
you know. Now, who's got the microphone problem?
Yeah, I know. I'm also having like my camera is auto adjusting. I need to figure out how to get it to stop doing that.
Yeah.
So I'm trying to adjust my lighting to
Okay.
match the whim of my.
Say when.
Hold on. Let me try one more fuss with my lighting. I'm just going to go with that. I'll be blown out. Um, okay, finding the record button.
Okay.
I am pressing the record button. It is recording. It
Okay.
looks a little bit low.
Yeah. That's what I'm afraid of.
Maresy dotes and dozy dotes and little lambsy divey. Maresy dotes and dozy dotes and little lambsy divey. A kiddly divey too. Okay, that's a little bit better. I'm going to start the
Okay.
recording over.
So I suspect it's going to pop up and totally change. So just watch your
Watch
levels.
it.
Yeah, watch your levels as you're recording, and I may even stop you in the middle of the recording and let you know what's happened. But
Okay.
all right, I'm
Okay.
recording. Are you still recording?
I'm now recording again.
Okay,
Sorry
well,
about
okay,
that,
let's
chat.
let's let's start that again together then.
Okay, hold on. Stopping.
Okay, say when.
Killing. When.
Okay,
Hi, Chad.
hello. Okay, well, that was your win, right? Of course. Okay, never mind. We're good. Hey, Chad. By the way, is back in Canada on the 14th, which is awesome. I can't wait.
Good.
I miss Chad. Okay, here we go. Astronomy Cast, episode 434. Am I on an alien world? Welcome to Astronomy Cast, our weekly fact-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. My name is Fraser Cain. I'm the publisher of Universe Today, and with me is Dr. Pamela Gay, the director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. How are you doing, Fraser?
Cold, really cold, and it's like super prime astrophotography here, but it's also super cold, which they got to go hand in hand because we need clear skies, and then it's super cold. But to support your astrophotography, I just wanted to let everybody know that we just published Dave Dickinson's 101 astronomical events in 2017, and we took it to the next level, and it's a book, like a 220 page book with 101 things to see in the night sky, totally free. There's no ads in it. There's no, I don't want your email address. It is just a free book. Go get it, download it. What I ask is that you just tell everybody. Like, just tell everybody. Like, walk into people on the street, show them this thing exists, let them download it too. We want to get this out as wide as we can. If a lot of people download it, then we'll do it again for 2018. And if people don't, then we won't. So it's all up to you.
So use your downloads to determine your future of knowing what's in the sky.
Exactly. And you, Pamela, you've got something to say.
I do nothing quite that exciting. So our show is funded by people like you. Without you, we can't pay Susie to remind me. We need a topic for Thursday or Friday, depending on when we record. We can't pay Chad to edit together our episodes. We can't pay Amazon to provide our web hosting. So it's the time of year where we go, help. Can you help, please? So Astronomy Cast, we have a donate page, astronomycast.org/donate. Please give a little if you can, and we will be setting up a Patreon. Stay tuned. That's a bit more tedious than one would think, but we're working on it.
Awesome. Once again, science fiction, television, and movies has totally let you down. They try to recreate what it might be like on an alien world, but surprise, surprise, they mostly get it wrong. That's because a truly alien world would be different in so many ways, it would blow your mind. Today, we'll help you figure out if you're on a movie set or if you've actually crash landed on an alien planet. And this is kind of in the news right now because we've got this video game, No Man's Sky, which purports to have you land on an alien planet. I have played it. I've seen people's complaints. The gist being that everything's the same, and it doesn't really feel that alien after a while once you realize it. So how do we want to attack this here? Let's say that I have woken up My spacesuit is screaming at me that there's a problem, and I need to figure out whether I can just take my spacesuit helmet off because I'm actually on an Earth soundstage, or I should leave my helmet on because I'm on an alien world and I might die horribly. Where should I start looking for clues?
Well, the place that you don't look is the sky. So one of the most endearing stories I ever heard was a Spitzer Space Telescope team scientist related this hilarious story about how he got into astronomy because when he was a small child, for some reason, he had this moment of being terrified he was going to be abducted by aliens walking home from school. And he wanted to know if he woke up in a random cornfield, if he was still on Earth or not. And he was worried that they'd like drop him in Australia and he'd look up and not recognize the sky. So he decided to memorize the southern hemisphere, even though he was living in America. And then as an adult, he had this horrible realization that anywhere you can get in a reasonable amount of time, even at a few times the speed of light, will still look exactly the same, ignoring the planets. So
Right.
looking up won't help you.
Right, because the when you look out into space and you see the stars in the constellations that you're familiar with, those are all monster stars because they're all the big brightest kinds, are very much larger and brighter than our own sun, and they are hundreds to thousands of light years away, and so you could go hundreds of light years away in almost any direction, and the constellations would still look roughly the same.
Yeah.
Did he get abducted?
No.
Oh, okay. Wah wah. All right. So what you're saying is like look up in the sky, look at the constellations. If you recognize the constellations, that doesn't mean that you've been transported to an alien world. But if the constellations look totally different, then you've got your evidence that you've been moved to an alien world.
Maybe. You have to know the sky really darn good and be able to recognize it from all sorts of crazy angles because as you and I experienced just going down to the Yucatan Peninsula, all of a sudden you have Orion laying on its side and other things change and it gets to be quite a bit confusing.
Yeah,
So
I was in Costa Rica and the moon, we were near the equator and the moon was flipped over on its side. And of course, the Australians. In fact, I'm going to go down a rabbit hole for a second here. So when we developed our Phases of the Moon app, we developed it with the moon the way it looks familiar to us in the northern hemisphere. And we had tons of people going, take a look at what it looks like from anyone in the southern hemisphere. It's the other way around. And we had to modify the app so we detect where you are and then rotate the moon based on where you live, which was a learning experience for us.
so if you can see that moon, however, the moon's a dead giveaway that you're still on Earth. And you can see the moon pretty much from anywhere on the Earth. So look for the moon, but not seeing the moon also doesn't mean you're not on Earth because it could be new or something annoying like that, or just on the other side of the planet.
Okay, but I still put if it's night and you look up and you don't recognize any of the constellations and you know your constellations and what you should see, then there's a good shot that you are not on Earth.
So keep that helmet on.
Keep that right. Okay, so great. So let's just be clear. Keep your helmet on. Okay, great. So what is the next major clue you're going to be needing?
Gravity. This is one of my pet peeves in television shows. I have gotten very ranty at many different shows because they're like, and now we're landing on this moon, we're landing on this asteroid, and gravity is Earth normal. If your hair isn't bouncing extra, if you're not bouncing extra, you're probably on an Earth-sized world.
What does what would that effect of gravity look like? I mean, like if you jumped up into the air, how would that feel?
So one of my favorite examples is you have on the TV show Eureka, they went to the moon Titan in theory, and they're getting off their spacecraft and they're walking down the ramp. and everyone's walking just like normal. But if they were actually on little tiny Titan, they'd be bouncing like we saw the astronauts on the moon bouncing. So every step, you'd be inadvertently heading a little bit harder towards that ceiling than you meant to be heading for it. And if you're on something tiny, like a comet, which is one of those things that they love to blow up in movies, you're probably going to weigh the same amount as like a piece of paper weighs on Earth, in which case you might just like jump off the entire comet by accident.
Yeah, and the classic example of this is something like Armageddon, of course, where they land on the surface of this comet the size of Texas, of course, or asteroid the size of Texas. Of course, there's only one asteroid that's the size of Texas, which is like Ceres, but still, and the gravity is kind of the same, and they're jumping, and they're driving their space truck around, and it's just clearly not. So I would be part of the Armageddon hoax conspiracy theory, seeing that kind of a footage. They didn't actually land on that asteroid.
No,
It was
no,
fake
that
in
was a
Hollywood
soundstage.
Yeah, right. But I guess, I mean, some of the one interesting thing that I've heard as well is like, if you fall off of, say, the Valles Marineris cliff on Mars, in the lower gravity of Mars, but also the lower atmosphere, you would, the terminal velocity is way higher, hundreds and hundreds of kilometers, and so per hour. And so in the beginning, you would fall more slowly, but you wouldn't stop falling more and more quickly until you were literally going, incredible speed. So you would actually hit way harder on the surface of Mars, for example, than if you were on Earth and jumped off the same
Yeah.
height.
So once you start getting to the point that gravity starts to feel closer to normal, enough that you can delude yourself that I just forgot what it feels like to walk, which is a pretty strong delusion to have. But let's go with it. You have someone hit on the head pretty hard, waking up on a new world. How things fall varies with atmosphere, and it isn't just how things fall, but it's how sound travels through that atmosphere. So the thunk they make when they hit the ground also changes. So you can do the good old fashioned drop experiment and watch to see, does it fall super weirdly slow? We've all seen things fall a million times. And then when it lands, does the sound it make sound anything like what we're used to?
I wonder. I mean, I guess you still have your helmet on, which was the wise move, and you've thrown the rock, and it follows an arc that you're very familiar with here on Earth, and then it whomps onto the ground, and you can still hear it through your spacesuit because you got one of those really fancy spacesuits. How will the sound change, and why?
Well, so first of all, it doesn't carry as well if there's super low atmosphere. So if there's super low atmosphere, first of all, you have the deadening of the sound. Then you also have to look at what's the composition of the atmosphere, because this changes we've all spoken in helium, and because it has a much lower number of it's a different sized atom. It interacts with the gas laws differently, all sorts of crazy physics. We can do an entire episode on why things sound the way they sound. Let's actually do that next episode.
I think we did. We do have an episode called Sound.
Okay.
Yeah,
so we're good. Go listen to that
right,
episode.
but the gist being, like, we talk about like things moving through a medium, and what that medium is will change the speed that the sound will move through it. I mean, if sound moves differently through water than it does through air, than it would through an atmosphere entirely of helium.
So helium will make things sound higher pitched. Things that have a higher atomic number than nitrogen does will make things sound lower pitched. It all depends on what that atmospheric composition is. And you can actually do occasionally deadly experiments with this. So I don't recommend this, but there are people who will inhale different non-toxic gases and then speak. The problem is that if you get some of the heavier ones in your lungs, you need to actually hang upside down and cough to make sure you expel all the heavier gases, because you're not going to do it casually on your own.
Yeah, I've seen that experiment. It's like someone has like I forget the stuff. It's like some kind of fluorine. I forget the stuff
Yeah.
that it is, but they breathe it in and then they just sound like the devil. And then they try like helium and it sounds super high
Minnie
pitched.
Mouse.
And so if you were on a planet, just literally the way sounds are getting to you, you throw that rock and if you don't hear the kind of thumping, the kind of sound that you are familiar with on Earth, then once again you've got a pretty good clue that you were on an alien world.
And so if you're hearing that super deep sound, it might just be an atmosphere of sulfur hexafluoride, which is that deep voice
Right,
gas.
that's the stuff I was talking about. Yeah, sulfur hexafluoride. Okay, great. Now, what about the light? What about what you're seeing all around you?
So the density of the atmosphere has a lot to do with how the light gets scattered. Composition is again going to matter. It always matters. But the density comes into play pretty strong on this one because you have the column density of the light that's able to do the scattering. So as light passes through an atmosphere, if it's thin like you have on Mars, your sunsets are blue. Your daylight is pretty white. If you have a thicker atmosphere, your noonday sun is red and your twilight is like a deep burgundy. You're not seeing the other horizon at all.
Right, and we've seen like the pictures of what the sunsets look like on Mars. We had a chat about this, that the sunsets on Mars are blue.
They're glorious. This deep, beautiful blue with the sun appearing white on the horizon, and the sky just doesn't scatter the same way. That's why you also don't get a blue daytime sky. So the thicker the atmosphere, the redder your sky is during the day. The thinner your atmosphere, the less blue it gets, and your eye just sort of gives up on perceiving it. And at a certain point, it's not even going to scatter enough light that you can see a sky. You just see stars beyond the atmosphere.
So, okay, so this is a good clue. So you look up and you see black sky, but also this burning orb. That's a clue.
That is a clue that you need to keep your helmet on because there's not enough oxygen or any other gas to scatter light outside of your helmet.
Now, you're not necessarily going to be able to see stars, of course, because your eyes are going to be adapted to that super bright sunlight, but you're
Right.
still going to have the blackness of the rest of the sky.
And what's cool is if you're smart enough to like turn yourself around so that the sun is directly behind you, then you can actually get rid of the blindness spots where you've saturated the chemical reaction in your eye and start to see stars on the opposite side of the sky once your eyes adjust, because there isn't brightness all around you. So you can essentially, if the ground isn't reflecting light back at you, if you're on a white surface, this won't work. But if you're on a nice non-reflective surface, just turning around, your eyes will adjust because the dynamic range straight in front of you allows you to perceive the stars.
So we just explained why the moon conspiracy people are crazy.
Yes.
This is why you can't see stars when the sun is in the sky and when it's really bright. Okay, so now what about the color of the sun? So if you see the sun and the sun is orange or the sun is red, is that a clue?
Um, Occasionally, and the reason I say occasionally is you can get a red sun here on Earth if you happen to be near a volcano eruption. So you go looking through that cloud at the sun, and that gas and debris in the atmosphere will scatter the sunlight. Now, if the sun is straight overhead and it's a crystal clear blue sky that you happen to see this funky red star in, that means that you have the exact right confluence of scattering and sun color, and the perfect math has happened to get this beautiful thing to occur, and you should keep your helmet on.
Right, right. I mean, here on Vancouver Island, we've got lots of forests, and during the summertime, huge chunks of the island are on fire. And so we get these terrible forest fires. And there are times when the sun is red, and I know I shouldn't, but I put on my sunglasses and I look at the sun, and it is like just this red ball in the sky that is.
Yeah.
It looks like I'm. What am I? Am I on Krypton? Like I'm on this place with a red world. Now, what if the sun was blue?
Yeah, that doesn't happen naturally. And I'm not sure our eyes would ever actually perceive a blue star as blue. I think we'd get so overwhelmed that we'd see it as white, just like we can't see green stars. Blue happens when you look at things like Rigel, but in general, if it's close enough that you see it as a star, I'm not sure that that wouldn't just be overwhelmingly bright, causing your eyes to go, nope, I'm out.
I like this. This just came from the chat. Orange Joe said, "I bet seeing two suns rather is a big clue as well."
Yes, yes. If you see sorry, Chad. If you see two suns, you may be on Tatooine or any of the other binary systems that have been discovered to have planets, and you're definitely not here, and you should keep your helmet on.
Right. Multiple stars. Keep your helmet on. Okay. Is there anything else? Any other clues that you've got? Now, what about the flora and fauna?
Yeah, if you start seeing mega reptiles, probably not the same. If you start seeing massive flying things with fur, not the same. Plants gets harder because at a certain level, there's so many weird plants that we as humans aren't necessarily used to. When I went to Indonesia, I spent a lot of time going, wow, look at that tree. Um, Apparently, I'm easily amused.
Yeah.
So I think it would depend on the nature. Now, if you're on a world that instead of having green chlorophyll, the plants are tuned to a different wavelength, which means you probably also have a different color sky, different
Yep.
color star. But if the plants are clearly tuned to a different color, which cropped up in some different episodes of Star Trek, that's going to be a giveaway. But if you see green plants that you don't recognize, it's a weird world out there.
Yeah, it really is. Yeah, you just mentioned cropped up in a couple of episodes of Star Trek in that they filmed in some Earth-based place and they just turned
With
the
a
plants
filter.
a different color.
Yeah.
So, once again. And of course, I think aliens, if you see aliens walking around, interacting with you, either telling you to take your helmet off or not take your helmet off, you should take their advice under advisement.
Well, if there's only one alien, you just might be on Earth and be that poor, unlucky side to make first contact.
Right, the aliens on our planet, and that you happen to right. But if they're all around you in their alien buildings, then you can use that as a clue.
Right. It's true.
Yeah. Anything else that we should be aware of as we're? So who has anyone ever done a good job of showing what it would be like to be on any kind of alien world?
Yes, Lynette Cook has actually done some really good artistry of what it would look like to live on various worlds, where she sat down with the scientists and figured out, okay, if you lived in a globular cluster, it would look like this. If you lived near a white dwarf star, it would look like this. So she's worked out a lot of the science behind how you get at the different kinds of skies.
But I literally can't think of any television show or movie that has ever done a properly good job of replicating it. And the gravity is the big one. Like, we loved The Martian, but still, it's 0.38, it's 38% of the gravity on Mars than it is on Earth. And so in literally every scene that Matt Damon is walking around, he should have been hopping around. They should have put him, like, if they really wanted to do it right, they would have put him on wires, and they would have made it. They either, would have figured out how to get him to walk around in a way that he was clearly. He would have been able to do things like jump across the habitat in one bound.
And that would be so much fun.
It would have been awesome, yeah. And now people have done zero gravity fairly well. I mean, there was The Expanse, which did a great job of handling the zero gravity. They didn't do such a great job once they sort of moved between zero gravity and some gravity. Actually, okay,
Right.
hold on. In The Expanse, there's an episode, there's a scene where one of the characters is looking at his window and he sees a bird flapping outside the window, and the bird is flapping in a way that it would if it was in lower
Oh,
gravity. And so it was sort of flapping, and then it was sort of drifting up, and then it was coming back down, and then it was flapping. And so it was actually done, but then he was walking around in normal gravity. And so it was just like, oh, you were so close. You just
well,
about had
and
it.
there's so many little things that you'd have to train yourself behaviorally to do different. Uh, Hair. I use my head a lot and move it a lot. And I would constantly be eating my hair indoors simply because the force of turning my head quickly to look at something, it would happily float up and it would just take much less effort to do violence upon yourself.
In um, Apollo 13, I believe they shot chunks of that movie in the Vomit Comet.
They did.
Yeah, and so that was actual microgravity. That was real, and they were doing things like drinking water and sort of zooming around through the parts of the spacecraft. That is utterly exactly how it is.
That's something else that would change the fluid dynamics. How things splash, how they move, how they change. Um, all of that would look slightly different and enough to just totally mess with you.
And Guido Bieber in the chat was mentioning that this was one of the reasons why the moon landings just looked so real, was
Yes.
because they were hopping around in lower gravity, which through the technology of the time and even now is incredibly complicated and expensive to try and fake. That the way they moved around and the way the dust flapped around their feet, that that is just such a hard thing to show, and it just went on for hours and hours and hours. So I think that in the future, when we have those first explorers land on the surface of Mars, it's going to look nothing like what it did in The Martian or
Right.
any of those movies, because they're going to move so strangely, and they're
Just
going to,
dust being suspended. The
yeah,
dust getting suspended in the air with less gravity, with less air, changes how dust works. And there's also electromagnetic fields. So you have this weird, it's not supported by air pressure, it's not floating around in the air the same way, but charge builds up. And so things electrostatically, it's this neat, crazy chaos of physics, which is glorious. And people get dissertations for figuring these problems out.
yeah, yeah. So I guess in conclusion, if you wake up on an alien world and you're not sure if it's an alien world or it's Earth, um, the gravity is going to be the big one. Like everything else, could be simulated, but it's really hard to fake the gravity. So if you jump up and you jump 10 meters into the air and then land again, or if you can barely pick yourself up off the ground and you feel like there's weights all over you, that should be your greatest clue. And then
Yes.
listen for the sounds, look at the sky, see what the atmosphere composition is, and go from there to try and puzzle out whether or not you've crash landed on an alien planet or it's just Earth.
Perfect.
And then it's perfectly safe to take off your helmet. All right, thanks, Pamela.
Thank you. And
Now
now
we
we save.
save.
Welcome to the boring part.
Yay. The fun part. Boom. 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 Okay. Thanks for the ideas in the chat, everybody. That was awesome. Okay, I will transfer that later
Yeah.
because Dropbox is the worst. Okay. Hugo asks, if you landed on a place like Flatland, how would the surroundings look, and should you keep your circle on your head? Should
Always keep your circle
keep
in
the
your head.
circle on your two-dimensional head. Everything would look like lines, right, of different
Yeah.
lengths if you were on Flatland. Seeing the world in two dimensions, it'd be very weird.
Yeah. What I love with Flatland is the idea that a sphere passing through A sphere, a sphere passing through flat land looks like a line that goes from a dot to a large line back down to a dot.
Yeah. No Rippenthal missed the episode, but you get to catch the questions. Everybody, if you want to catch a show when we do it live, don't ever forget, click on the little notification bell, and then you'll be notified the moment we start the show. David Joseph Wesley says there is a swimming pool scene in Passengers where the artificial gravity shuts down and Jennifer Lawrence is trapped in a giant floating sphere of water. Now, the cool thing about water is that if you are in the sphere of water, you've got the water pressure, so you can swim around inside the water, right?
Right. So the water is happy to let you swim around in it. Fish have been in space. They're sort of kind of cool with it. The whole how do we orient ourselves, especially if you screw up where the light's coming from, really confuses them. But they can swim.
Michael Meyer, did you read Protector by Larry Niven?
No, I haven't read that one.
I have, but it was so long ago. I remember the cover. It's like sort of this creepy alien sort of hunched down. I'm trying to remember exactly what it was. But I did read it, and I could read it again. I love Larry Niven, but... okay. Our Instro asks, is geology ever a big enough clue to go by? Olympus Mons the distance?
Yeah.
Well, remember, the Olympus Mons can never be in the distance.
Well, true.
Right, because the curvature of the planet means you can never see the top of it. It just looks like the sloping off into the horizon. I've read that the mountains on Venus are much steeper sided thanks to all the water being baked off.
Say that again?
What he's saying that I've read that the mountains of Venus are much steeper sided thanks to all the water being baked off.
Steeper sided has to do more with gravity than anything else. So Venus is slightly lower gravity than Earth, so you can end up with higher things. And then the angle of recline is a combination of gravity and composition. So just like you have Ship's Rock in New Mexico, which has an amazingly steep, you have El Capitan in Yellowstone, or Yosemite rather, has a really steep incline. You combine that angle of incline with how big it can get in a given gravity, given its composition. So it's not as simple as the water baked off.
From Doug Joseph, what would it be like if everything was reversed? So instead, walking on the outside of an Earth, you walked on the inside and the sky was within it. Well, so you'd be in an O'Neill cylinder, right? You're in an O'Neill cylinder and it's turning,
Yes.
and you're feeling artificial gravity because of the centripetal force.
Okay, sorry, I got
one of
inside
the forces.
the Earth, and I was literally like, "You're in a cave."
No, and so then you're seeing the inside of the O'Neill cylinder sort of stretch up above you, curve up, and then you're seeing like clouds up above you, and then you're seeing the other side of the cylinder on the other side. Yeah, that would be a pretty good evidence that you are on an O'Neill cylinder.
Yeah, but you aren't on an alien world, which was the premise of the episode. Just to be legalist.
Really? You don't think that that's an alien world?
I think it's
I
an
think
alien
it totally
superstructure.
counts.
It's an alien superstructure.
Alien superstructure. Oh, great. An alien megastructure, specifically.
Yes.
Yeah, no, I think it totally counts. I'm totally with you, Doug. Let's see. Oh, and Zach Cody's mentioning Rendezvous with Rama, where they have a cylindrical world. I haven't read Rendezvous with Rama. That's like... is it Rama? Rama? I don't know.
I read that one so long ago, I don't remember. I need to reread some of my classic.
And Noel Rippenthal says that a 4D hypersphere passing through our space would look like a random sphere growing and shrinking in and out of existence.
True.
There you go. Let's see. More questions. Keep them coming. Let's see. I thought I saw some questions in there. If not, we're just done. We're wrapped up. Oh, one thing I did, if you're looking for even more ways to interact and engage with us, which was I created a Universe Today group on Steam. Although maybe we should do an Astronomy Cast. Anyway, and I can do 400 friends on Steam. So if you haven't
That's
already,
cool.
friend me on Steam, and I'll friend you back. I haven't seen a lot of spammers come in through Steam. And then
Yeah.
let's think of some ways to game. I'm a gamer. I got 1,000 games on my Steam library, tons of space games. I'd love to, figure out a way, like even do some Twitch streaming and just to hang out and do some space games. We're gonna have the folks from Universe Sandbox back on the weekly space hangout in a couple of weeks, but that
Cool.
kind of thing. Like I can get the developers of these games to come and hang out, or astronauts, or all kinds of people. So I'd love your ideas on what we could do with with games and space, etc.
And 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 I need to find time to play games.
First, have children, and then and then but the way you spend time with your kids, you play video games with them.
I think there's probably some shortcuts in there.
Maybe. David Joseph Wesley asks, any AAS conference news that have you guys excited? Well, if we did, we would be under embargo, and so we wouldn't be allowed to talk about it. But I refuse all embargoes, so I have no idea what's going on. Presby B asks, are gingers really aliens?
No.
But do they have a soul?
Yes.
Okay. This is a South Park. EVE Online. Chocolate Witch says we should play EVE Online. I've got an EVE Online account. That's a rabbit hole. Man, I can't. Those kinds of games are just they're the worst for me. Thomas Tranico wants to know, what kind of telescope do you most desire?
A teleview refractor, apochromatic refractor,
How big?
as big as I can get that will fit in an overhead bin.
Oh, so you want something that you could take places.
Yeah.
Okay. What is one of those run?
Um, thousands.
Just how many thousands?
I haven't looked in a while because I know I don't have that.
Yeah.
Yeah.
What's my Steam profile name? It is Fraser Cain. Like my name. Would surface tension keep the water in the pool unless there was a change of direction of thrust?
Would surface tension keep the water in a pool if there is sufficient uh, bonding with the sides of the container and there are no forces acted upon the
Right.
system at all?
Right. And I'm sure, I mean, I haven't seen the movie, but I'm sure, the water, the gravity shuts off and then the water sort of floats up out of the swimming pool and forms this sphere in the middle of the room. And but it wouldn't float up. If there was no forces, it would remain precisely where it was. There would have to be some force, like the spaceship moving down, for it to then move up and lift up out of it. And then depending on, I guess, the speed, the amount of surface tension would keep it in the pool unless it was too much, and then it would pop out. So another one debunked, and I haven't even seen the movie. I could have seen the movie. They wanted us to see it, and I don't know if you got a bunch of publicity stuff about it to see it, but
It may have gotten spammed.
no
I
one,
didn't notice
yeah,
it.
nobody invites me to see movies in my local Courtney Cineplex, so I have to go to some big city if I want to see these things. So Hugo wants to know, human see color on Earth. How would color look on an alien world, and would there necessarily be any color at all?
We'd still see color. The chemical reactions would still work just fine in our eyes. The photons would be exactly the same. What changes is how light gets scattered in the atmosphere. So if you think things look different in a fog, things look different when the light gets filtered through clouds or through lava. Well, not through lava, but through ash thrown into the atmosphere from an erupting volcano. Um, if you're on an alien world, you still have the light. It's still going to interact with your eyeballs. It's what happens to that light between the star and your eyeballs that gets varied from world to world.
Right. Janelle Duncan wants to know, how do we know what the Milky Way galaxy looks like when we're in it?
So that one comes down to a variety of different surveys have been done that have used a variety of different techniques to measure the distance or estimate the distance to all of the stars that we can see. And then that gets put into a three-dimensional model. We put together the model, and then because it's in a computer, we can move ourselves. Sloan Digital Sky Survey is one of the big workhorses for doing this, but it's only done part of the sky. It's over time. So many different surveys have been put into play to figure out what's the map in this distance, what's the map in this direction, rather.
Yeah.
And by adding all of that up, you eventually get to the point that you have this model that you can rise up above the disk, look down at it. And there's certain places where we're just estimating because we can't look through the galaxy super effectively because there's stuff in the way. And you can get through it using longer wavelengths to a point, but you can't map star by star by star through all of the dust and gas and everything else.
Well, I use this analogy of like, we're inside a house. So how do we know what our house looks like from the outside? Now, obviously, we go outside. Now, if you looked out your front window of your house and you saw a whole pile of other houses and they were different, but you then measured the inside of your house and then looked out at those other houses and found a house that had sort of the same dimensions and the same number of bedrooms and the same number of stories and the same size yard, at a certain point you'd be okay, like an artist illustration of our house is that house over there. So when we see pictures of other galaxies, they're all artist illustrations of the Milky Way, but we are seeing other galaxies that have the same characteristics as our galaxy, and so we can say that one is very close. And there's a couple that are very, very similar to what the Milky Way looks like. And so it's just, but absolutely, we cannot see what our galaxy looks like from the outside because we're embedded in the middle of the disk, and so we're always going to be seeing our house from the inside. Lillian Brennan wants to know, would the atmosphere change the Doppler effect on sound?
Oh, yeah.
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 Yeah, so you would get what the atmosphere was made out of, but also the pressure of the atmosphere. And
it's a
even
constant.
The gravity would change the pressure. So
it all goes in
Yeah.
on a constant that comes from the pressure of the atmosphere.
Yeah.
Pressure and composition combined of the atmosphere.
Alex Desplan wants to know what my icon is. It's just the Universe Today logo is my Steam account. If I can open up my Steams. Yeah, it's just Fraser Cain is my profile. Let's see. I think this is safe. Let's see. There's me. I played way too much Europa Universalis. Okay. David Joseph Wesley wants to know, would we be able to see the color and beauty of a nebula from within the nebula?
No.
No. I love this question and I love this answer. Mostly because I really like raining on people's parades.
It's super frustrating because most nebulas are actually like as diffuse as a vacuum that we can make with a cheapy high school lab vacuum. And so you suck all the air out in your high school chemistry class, and what's left behind is as dense as most of those nebulae. And so that beautiful structure that we're able to see is stuff that's like solar systems and light years across, and it's only with great distance that you're able to have enough scattering to get the pretty colors.
Right. So there's this idea that as you get closer, the surface brightness, as you get closer to a thing, as it takes up more of the sky, then it gets more spread out. So
And
the
the surface
terrible
brightness goes down.
yeah, so the terrible truth is that you could take your spaceship and fly it right to the Orion Nebula, and it wouldn't
Mhm.
look any better, even if you were super close to the Orion Nebula, than it looks when you're further out. That as you get closer, it just gets more. The surface brightness gets spread out, and it just gets more diffuse. And a great
Yeah.
example of this is like people imagine like what would happen if you could see, in 5 billion years when Andromeda is about to collide with the Milky Way. Well, you see this enormous galaxy in the sky, but you won't. We're in the Milky Way right now, and you know what it's like to see the Milky Way.
Yeah. It's
So,
sad.
yeah, you need to go to like dark skies. You need to have no light pollution, and you need to wait till it's really dark, and then you'll see this kind of this ghosty shape in the sky, and that's the Milky Way. And so when Andromeda is just about to collide with us, you will see this kind of ghostly, cloudy sort of area in the sky, and if you use a telescope and you take a really long exposure image, then you'll get a shot on it. So those movies where maybe that's a whole other episode, is like, how do I know if I'm in the Mutara Nebula? Which is like they did it in Battlestar Galactica, and they did it in Star Trek, and they do it all the time where they're
And it
flying
doesn't
past nebula.
work.
It just doesn't work. Yeah, so David Joseph Wesley says, so it's completely possible that we are currently inside the most beautiful nebula in the universe, unblissfully ignorant. Yeah,
We
well,
would
no.
actually know
We would know.
because it would affect the perceived light of all the stars around us. So when we're looking out in different directions, we see what's called a reddening effect, and this is caused by galactic dust. So we can measure the amount of dust in any given direction at any particular distance interval based on how reddened is how much red light is scattered out of the black body of things that we're looking at between here and there.
Yeah. So that question is absolutely something that astronomers have wondered, and they have a method, which is to search for the reddening of the sky based on the dust that surrounds us, and they know how much there is, and they use that to calculate the density of material in the interstellar medium. So, yeah.
Sad yet true.
Sad yet true. Yeah. That would just be the biggest bummer to go on a sightseeing cruise to the great nebula in Orion, and you get up close and you're like, where is it? It's all around us. Can't you tell with these really sensitive instruments that can detect the amount of reddening in that direction?
Yeah, no, you
Wah,
can't.
wah. Let's see. Arnstro wants to know if I got dropped onto an ice scape, can I tell if I'm on Earth or not Earth based on the ice I'm standing on? Antarctica versus Enceladus.
Not so well.
Okay, so hold on a second here. Let's just think this through. So liquid water creates, it provides that pressure, right? Liquid water provides the pressure. And so if you're down deep in liquid water, you have extreme amount of pressure. And if you're high up, then you have the kind of pressure you're used to when you dive in the water. You go down, 10 meters, and your ears are going to be hurting. So you're going to get ice forming on the top of it, and it's going to float, and you won't be able to really tell. I guess, if you jump around on it and feel how you move with the gravity, that will tell you. But
Right.
apart from that, you wouldn't, would the bubbles in the ice be of different sizes depending on the gas that's...
But bubbles in
Yeah.
the ice on Earth are all different sizes anyways.
Yeah. Yeah, I can't think of any way that you would be able to tell the difference just by looking at the ice to know which one you're on. We did an episode about sort of this in the Guide to Space, talking about how there's a few places you could be in the solar system without a helmet, and one of those is if you could just dive under the water on Enceladus and swim around. You could do that and not need any kind of spacesuit. You would just suffer, as long as you can figure out a way to breathe. Take a scuba suit and a warm suit,
Yeah.
then you're going to be right there, because literally the fact that there is liquid water means that the conditions are right for liquid water. right? Like, if that makes, I know that was very circular, but
No,
anyway.
it's all good. Sorry, my dog was destroying
Oh,
something.
nummy.
Yeah.
So, Doug Joseph, you could live in a nebula. Which one would you pick? None. Does, which?
Now, a globular cluster would be kind of cool.
Oh yeah, yeah. Because they're giving off light. You've got point stars giving off light. You want to be close to a cluster. So you've got this like almost like a star-like, a sun-like cluster way over there, but not so close that it's you're in the middle of it and you just never get night. That would suck.
That would, but that whole outskirts of a cluster, that would be fabulous. Unfortunately, they're low on metals, so probably not high on planets.
Yeah. It'd be weird though. I'm thinking about that, right? Like that if we were in something like the Orion Nebula or like some super nebula, that astronomers again and again would be like, people, you've got to understand that we are in the biggest nebula that we can possibly imagine. It's amazing, and nobody would even be able to see
Yeah.
it. You'd have to be far away.
Well, and if you were in the middle of this amazing nebula, you'd only see other stars that were embedded in the nebula with you. And everything else, the light would be diminished by this amazing nebula that you're in.
Yeah,
So you basically live in a cloud of slightly glowy stuff.
it would suck.
Yeah.
Yeah, it would suck. All right. Well, I think we're reached the end of our time here. Just a reminder, so the weekly Space Hangout is going to be tomorrow at the same bat time, same bat channel. We're going to be doing Astronaut Abby is going to be joining us, which is going to be a lot of fun.
Excellent.
So join us tomorrow at 12 p.m. Pacific. Now I'm going to go shoot some more episodes of The Guide to Space. So if you're wondering where that went, that's about to happen. We're going to be talking about how we change our bodies to adapt to Mars. And I don't even remember what the other topic was, even though I just did it. Anyway, yeah. So we're going to do those episodes. They should be showing up in the feed in the next couple of days. So
Sounds awesome.
thanks everyone for joining us. Thanks Pamela for of course bringing the brain. Big thanks to the folks at the WSH crew, of course. Make sure you join that community if you want to be on the inside track and be our best friends. Join the WSH crew. .space I believe is their new super cool URL. All right.
Yes.
Thanks everyone, and we'll see you all next week.
See you.
Bye. Stop streaming.
Eddie is totally losing it over here.
Aww.